Hi, welcome to the Brain Gauge channel, and today we're going to look at how you look at specific scores. This is a question we get a lot. People are very interested in not just getting an overview, but understanding better a little bit about what the scores mean. And just to recap, the figure that you see or to the left is the brain gauge connected to the laptop and showing the results, the typical results that you might see, which has a tracking history plot at the top, typical results to the left, and the raw scores to the right. So let's get started. And here's another overview where we're looking at overview of poor results, mixed results, and good results, and it's fairly intuitive. Red is bad, green is good, short is bad, long bars are good. And you've got two different modalities you can look at. You can look at the bar graphs at the top or the radar plots at the bottom. It's pretty simple, but let's see what all these labels mean. We see a bunch of labels we see a bunch of labels here. All these words mean something, and they all mean different things. So we're gonna take a look at these individual measures. And right here, what I did was I cut and pasted to the horror of a lot of production type people. I cut and pasted from our website and put the speed description. You can find this on the website itself. And speed is labeled right here. This is the first measure we're going to talk about. And it is also labeled right here on the radar plot. So at the top, you've got the bar chart, speed's at the top, and then you can see speed indicated on the radar plot. They mean the same thing. When it's contracted, it's not a good score. When it's full scale, it is it's a pretty good score. And in this particular case, speed goes from bad to good. Now, speed is computed from reaction time. I like starting with reaction time because it's the simplest measure to talk about. And it's simply you feel a stimulus on your finger and you respond as fast as you can. It's that simple. And everybody that's taken this test knows that you sit there and you can actually see your results. It's the one test you can see the results right away on every single test, and you'll see a number pop up on the screen. And the first time you might take it, and you'll see on your first try, you might see 260. And the next time you might see 160. The next time you might see 200. And next time you might see 300 and 160 again or something like that. But anyway, you'll get an average, and that average is your reaction time. And how much it changes and varies from one to the other is your reaction time variability. Both of those scores have meaning, and they both are factored into your speed score. Speed is, or reaction time itself is really dependent on white matter integrity. And basically, if you disrupt cortical networks, you slow things down. And if you go back to your high school biology, most people remember, that white matter is a myelin that wraps around the neurons and allows neurons to go fast. But if you disrupt that, things go slow. But the other thing that happens is, if you disrupt it, that things do get very variable. So whereas you might take the test and go 200, 200, 200, 200 just every single time, and your reaction time variability would be very low, then that means you're very focused. And so that's one thing to think about, is like if your mind's not wandering and you're very focused, you can really concentrate on that test and you'll do very well. And your focus score will be right here and right here. And that score is very strongly related to your reaction time variability. And reaction time variability has also been correlated to attention as well as white matter integrity. And as you can guess, adolescents with ADHD don't do too well on that score. I mean, that's pretty well documented by other researchers besides us. So you can't just blame us for that one. Now, one other score that you get from reaction time, if you'll notice, if you take the regular battery, you'll take reaction time at the beginning, you take reaction time at the very end, and what you get is, from that we can compare. And if you do very well at the beginning, and then at the very end you do kind of poorly on reaction time, well, that means your fatigue score is going to be very low. But if you do very well on both of them, then you'll have a very good fatigue score. In other words, it indicates you're not fatigued. And that fatigue score is third from the bottom, right here, and it's right here. So that's sort of, you really can't do that unless you do full battery of tests, because it's a measure depending on you taking a minimum number of tests. You can't get tired if you don't do the tests. Okay, so a lot of things get disrupted and can by these measures that you see. If your speed measure in particular is often disrupted with concussion or TBI, different neurodegenerative disorders, anything that disrupts the white matter. Accuracy is the average amplitude discrimination task. You can see the label for that right here and right here. And basically that just, amplitude discrimination is a test where we just say which one is larger, and it's an indication of contrast enhancement. And this goes on predominantly in the parietal lobe, but it's a really good indication of how the whole system's working. When I'm talking about the whole system, I'm saying, well, if you took a drug, your drug will affect the whole part of the brain. If you drank, or if you didn't get enough sleep, or anything that's systemic is something like a pharmacological insult or some kind of broad-based neurodegenerative disorder. It will impact this measure. Okay, let's go on to the next one. Next one's TOJ. Now, temporal order judgment is one where we ask which of these two taps came first. And so basically it's this wind pathway, which is more frontal than the others. TOJ can be seen right here, right there in the middle, and right here on the radar plot. And that is, again, more frontal parietal. It's more of a non-systemic measure, though if the whole system shut down, you won't do well on that, on TOJ as well. But it's kind of a thing where if the front part of your brain is kind of messed up, then you might have a lot of trouble with that. The extreme case with that is with, say, schizophrenia. Schizophrenics have real trouble with understanding order. Now, a less extreme case of this is dyslexia. Dyslexics have a little trouble with this test. Adolescents with ADHD also have trouble with this particular this measure. But anyway, people that are concussed in a certain part of their head, if your whole brain is kind of insulted, then you can see, like in this case, all the measures as well as TOJ were impacted, but it does get better with time in the concussed subject. Okay, and finally, last but not least, is timing perception. Now, timing perception is a metric. It's done with a test called, we compute this with a test called duration discrimination. And basically, duration discrimination is where we deliver one stimulus that's one length and another stimulus that lasts a little longer, and we ask, which of those two stimulus lasts longer. You can see timing perception is right here. That's the score. And one thing to realize is that when you look at raw scores, you'd be looking at duration discrimination if you look at the raw scores. And what you'll notice is that as your duration discrimination score gets lower, your timing perception goes up. That's the same for TOJ and for amplitude discrimination. For all these scores and reaction time, the lower the score, the better you did. Faster your reaction time, the better your speed score. The lower your timing perception score means a smaller, just noticeable difference that you could detect, the higher your timing perception score. Now, timing perception has a lot to do with the cerebellum. That's the back of the head. And if you get whacked in the back of the head, you may have a little trouble with this. Parkinson's patients also have trouble with this. A lot of other neurodegenerative disorders have trouble. But the way we know that it's the back of the head is from some studies where people use something called TMS, or transcranial magnetic stimulation, to block activity in the back of the head and then do a timing perception test. And it turned out that when you block activity in that part of the brain, you can't do this test anymore. So that's one way people know where different tests and how you can test different things. So this sort of concludes this short video. And if you want to find more information, you can go to the website, corticalmetrics.com, and go under the support page, and you can see where, and go to the score specifics. And that's basically what I just told you about.